So, once we have a pretty clear understanding of the coding side of unit tests, in other words, know and appreciate the elements of coding them, so this is knowing how to create a test class, knowing how to write test methods within that class, etc. Now that we have that under our belts, it's time to look at some general guidelines for unit tests. So here we'll look at the most important characteristics of unit tests and get an appreciation of some fundamental rules we need to stick to. Probably the most important point is that a unit test should be isolated from anything external to it. We need to have isolation away from any external factors. So the class being tested shouldn't connect to anything which is usually in its operational environment. By external, we mean external in a heavy sense, so a different process or system, for example. So this means no database access to perform queries or insert or update data, no accessing messaging systems to either send or receive a message, and no network connections. So we don't want to read from a socket or open a connection to anything external. And by the way, this includes HTTP requests too, so don't try and invoke any REST-based APIs either. There are a few ideas behind this, but the main one being that we're minimizing the moving parts. The less stuff we have involved when we invoke the method we're testing, the better. Because if something goes wrong, it should be clear what that something is. And if we have too many moving parts, too many things involved, it just won't be clear to us when something does go wrong and a test fails. If we have our class under test interacting with different systems, involving different code and possibly different technologies, etc., we lose that scientific method quality we need in unit tests. We just want to set up the unit test class with the minimum we need to put it into a testable state, invoke the method we're testing, and then observe the results. Ultimately, when we switch hats from being a developer writing production code to being a tester writing test code, we should approach that role very scientifically. Set up the minimum you need for the test with the minimum moving parts. Effectively isolate your class under test from the things it interacts with externally, and then you can observe how the class will behave under different conditions. Of course, the class under test still needs to work with its so-called collaborators, so it's not isolated in the sense that it doesn't interact with anything at all. That would be impossible. It just means that it's isolated, and this is the key part, from the real thing. This is where our mock objects come into the picture. Using mock objects lets us provide substitutes for the real thing, for those so-called collaborators. And it's through these substitutes, these mock objects, that we can start to get scientific about our testing. We can control how we want the mock objects to behave during our tests. We could, for example, provide a mock object to simulate a database, probably more likely a JPA repository being in Springworld, say, and choose that for a particular test, that mock object will throw a SQL exception when it's accessed. This allows us to test the execution path, that is the flow of our application logic in the class under test, when we encounter that kind of exception. In another test case, we might decide that we want to test a happy flow, so we set up the mock repository object up to play nicely in that one, and return some canned results we're happy for the class under test to work with in that test. So the isolation angle is really that the only code that is real when the test is executing is the class under test. This is the real code we'll be running. But the collaborators it interacts with, those collaborators around it, these will be fake, our stand-ins, those mock objects we've been talking about. And by controlling these mock objects, we can start to build up a suite of tests where we just change one thing at a time and observe the results as we're doing so, and testing those different flows through our code, making sure we're getting the right results. Now that we have this notion of isolation in our heads, let's see what further benefits this brings. Well, because we're detached from anything external, it means that our tests execute quickly. That's another key aspect, speed of execution. We want our unit tests to run as quickly as possible, because when we do that, we'll be continually running them as we change the codebase to either implement the feature or fix the defect. If they're quick, this is the benefit that they'll actually be run. We want to be running our tests not as an afterthought just before we commit our code, but continually as we develop. Running unit tests should be part of your developer workflow, and that can be either through running them in the IDE when you choose, or running them from the Maven or Gradle build. Now, we're not as extreme as watching for source file changes to trigger unit test execution, although you can do that, but we need to be judicious and run them as much as possible when developing. It's another tool in our developer toolkit to ensure that we stay on track and can move fast without breaking things in the process. Also related to isolation is that test runs should be consistent. No matter whether we run a particular test once, 10,000 or 1,000,000 times, we should get the same result each time. It shouldn't depend on when it's run, where it's run, or on which operating system it's run. Don't do anything in your test code which is specific to certain times of day, for example, or specific to which type of machine it's on. So for example, your local workstation are running as part of a continuous build process on a system like Jenkins. Now, keep things simple and repeatable. After all, if you can't predict how your test will react based on external factors, it's not that much use, is it? Also, unit tests should be reliable too. This is related to consistency, but the test shouldn't only pass if run in a certain order, or when run together, or be a run this one first and this other test will work type scenario. There should be no concern for ordering, and moreover, no dependencies between tests. That's the key takeaway for this one. Finally, if you put all these things together, these special ingredients if you will, they'll make sure that you actually end up running the tests regularly. In this way, they're an early warning mechanism. If you're running them regularly, you can correct your steps as soon as some test code starts failing. Whereas, if you run them at the end, you'll have a batch of tests which don't work, and then it will be difficult to find out which changes broke which tests. Run your tests regularly, code quickly and backtrack swiftly when needed. In this way, your unit tests act as a compass to keep your coding direction going the right way.